Today, we will explore a hot topic in the field of aviation: hypersonic aircraft, machines that can fly faster than the speed of sound and promise to completely change the way people move. In particular, there are rumors that Elon Musk, the man behind bold projects such as Tesla and SpaceX, is developing a secret hypersonic aircraft with the ability to surprise the world. Is this technology really feasible? What challenges await on the road to conquering supersonic speed? Let's find out this interesting story in today's video. And don't forget to like and subscribe to the channel so you don't miss the next interesting content. Let's get started. Hypersonic aircraft are opening up a promising future in the aviation industry. These are vehicles capable of flying faster than the speed of sound, Mach 1. Equivalent to about 1235 km per hour, significantly reducing travel time on long routes. If a normal flight from New York to London currently takes about 7 to 8 hours. With hypersonic technology, this time can be reduced to 90 minutes. This not only brings convenience to passengers but also changes the way people connect globally. Aviation and technology companies are racing to join the hypersonic revolution, bringing this idea from the drawing board to reality. Notably, names such as Hermet, Boom Supersonic and Hypersonics have made significant strides in developing high-speed aircraft models. By applying advanced materials technology, improving engine systems and solving aerodynamic problems, these companies hope to open a new era in air transportation. However, more notable is the rumor of a secret project from Elon Musk, famous for his ability to turn far-fetched ideas into reality through companies such as SpaceX and Tesla. Elon Musk and the space company are said to be developing a hypersonic aircraft project called X-1. Although still shrouded in secrecy, the X-1 has attracted the attention of experts because of its bold claims about its capabilities. Not only can this aircraft reach speeds of up to 4.600 miles per hour, about 7,400 kilometers per hour, many times faster than the speed of sound, but it is also equipped with advanced stealth technology, making it almost invisible to radar. This is a huge step forward compared to current military aircraft and could revolutionize the field of military aviation. The special feature of the X-1 lies in its advanced engine system, which is an improvement from famous engine lines such as Merlin and Raptor, technologies that SpaceX has successfully applied on space rockets. This system helps increase fuel efficiency by up to 30% compared to conventional military aircraft, not only stopping at military purposes. The breakthrough technologies of the X-1 also open up the potential for application in civil aviation projects in the future. However, for a supersonic aircraft like the X-1 to operate effectively and safely, engineers face many technical challenges. The difficulties include managing the enormous heat generated by friction at supersonic speeds, improving materials to withstand extreme pressure, and optimizing the engine system for stable performance throughout the flight. These hurdles require not only great innovation but also huge investment resources. However, with Elon Musk's track record in major projects like SpaceX and Tesla, many believe that the X-1 could be the next breakthrough, bringing humans closer to the future of supersonic speed. To successfully develop supersonic aircraft, engineers and scientists are facing many major challenges, both in terms of technology and practical operation. One of the biggest barriers is the ability to manage temperature. When flying at supersonic speeds, friction with the air creates a huge amount of heat that can heat the aircraft's skin to thousands of degrees Celsius. This requires the use of advanced materials that can withstand heat well, ensuring safety while maintaining flight performance. Not stopping there, the engine system is also a difficult problem. Traditional engines are difficult to operate stably at supersonic speeds because the extremely high pressure and temperature can damage internal components. Therefore, developing a hybrid engine, combining turbojet and ramjet, like Hermet is doing, is a potential solution but also contains many technical challenges. In addition, the development of supersonic aircraft also requires special cooling systems to protect the entire aircraft structure and engine during flight. If this problem is not properly resolved, the heat generated can damage or even melt important parts. Another challenge is fuel efficiency. Flying at supersonic speeds consumes a huge amount of fuel, which requires developers to find ways to optimize engine performance to save fuel and extend the aircraft's operating range. In addition to technical factors, noise and safety regulations are also significant barriers. At supersonic speeds, when an aircraft exceeds the speed of sound, it creates a sonic boom. affecting densely populated areas. Currently, many countries such as the US have banned supersonic flights over land, forcing supersonic aircraft to only reach their maximum speed when flying over the ocean. This significantly limited the ability to exploit and use this technology in practice. The Concorde was once a symbol of the golden age of supersonic technology in civil aviation. Launched in 1976, Concorde could fly at speeds of up to 1.354 miles per hour, twice the speed of a conventional commercial airliner, allowing passengers to travel from New York to London in just 3 hours, instead of 7 to 8 hours like traditional flights. This was a great achievement, marking a major step forward in the aviation industry and becoming a symbol of luxury and advanced technology. However, the success of Concorde also came with difficult-to-solve problems, leading to its cessation of operations in 2003. High operating costs and high fuel consumption made tickets expensive, serving only a limited group of customers. At the same time, Concorde also faced opposition from countries due to the sonic boom, which greatly affected the areas it flew over. Strict noise regulations meant that Concorde could only achieve its speed when flying over the sea, reducing its flexibility and economic efficiency. Despite the failure of Concorde, it left a huge legacy and was the basis for companies such as Hermet, Boom Supersonic, and even Elon Musk to develop new supersonic projects. These companies not only focused on speed but also tried to solve the core problems that Concorde had, such as reducing noise, improving fuel efficiency, and increasing operational flexibility. Hermet, with its Chimera engine, is aiming to go beyond Concorde by combining advanced technology from the aviation and aerospace industries to create feasible and sustainable civil supersonic flights. Looking back in history, the success of Concorde demonstrated the potential of supersonic technology to shorten travel distances and times. However, technical and cost limitations put this dream on hold. Today, with advances in technology and strong investment from major corporations, a new era of supersonic aviation is gradually opening. Hermet's Quarter Horse project is a breakthrough in realizing the dream of supersonic flight in the near future. The Quarter Horse is not a single aircraft but a series of prototypes, Mk0, Mk1, Mk2 and Mk3, developed in stages to test and perfect new technologies. Hermet aims to push the speed limit of aircraft, even surpassing the record of the state Route 71 Blackbird, the world's fastest reconnaissance aircraft, at 2.193 miles per hour, Mach 2.85. What is remarkable is that the project was completed in a very short time thanks to Hermet's flexible and efficient approach. At the heart of this project is the Chimera engine, a breakthrough technology that combines a turbojet, used for initial acceleration, and a ramjet, operating at supersonic speeds. This engine solves the disadvantages of traditional engines when flying at different speed ranges. While turbojets work well at low speeds, ramjets are only effective at high speeds, Mach 5 and above. Chimera uses turbojets for takeoff and acceleration, then switches to ramjet mode to maintain supersonic speeds. This is a huge leap forward in aviation technology, making the aircraft more efficient and cost-effective. Hermet also leverages off-the-shelf engines such as the General Electric J85 and Pratt & Whitney F100 as the foundation for Chimera, saving billions of dollars and shortening development time. Combining off-the-shelf components with new technologies developed in-house has created a huge advantage, allowing Hermet to go further without the huge costs of other companies. The Quarter Horse project is divided into 4 main development phases, with each prototype version, Mk0, Mk1, Mk2 and Mk3. Each phase has a specific mission and contributes to solving the challenges in developing a hypersonic aircraft. Mk0. This is a ground test prototype, which plays a role in evaluating control systems and the ability to integrate new technologies before airborne testing. In early 2024, Mk0 completed important tests such as remote control, speed testing and evaluation of the communication system between the aircraft and the ground control center. Notably, the design and testing process of Mk0 took only 6 months, a testament to Hermet's impressive development speed. Mk1. As the first version of the drone, Mk1 will conduct real-world test flights, including high-speed takeoff, acceleration and landing. The first flight of Mk1 is expected to take place in late 2024 at Edwards Air Force Base in California. The fact that Mk1 was developed in just 7 months demonstrates Hermit's ability to rapidly test and improve. Mk2. At this stage, Mk2 will be equipped with an upgraded version of the Chimera engine. Using a Pratt & Whitney F100 core instead of the J85 in previous versions. Mk2 aims to break the sound barrier and reach a speed of Mach 2.5, 1,918 miles per hour. The success of Mk2 will mark a major turning point in demonstrating the autonomous and stable operation of supersonic aircraft. Mk3. This is the most ambitious version of the project. Aiming to break the speed record of the state Route 71 Blackbird and reach a speed of Mach 4, about 3,069 miles per hour. Mk3 will test the ability to switch between turbojet and ramjet modes during flight, a key factor in maintaining supersonic speeds. The Quarter-Horse project is a testament to innovation and daring in modern aviation. Hermit's flexible approach, using off-the-shelf components and incorporating new technologies, has enabled it to save significant costs and accelerate development. Hermit's ultimate goal is to make supersonic aircraft a reality, not only to break speed records but also to usher in a new era of air travel. The success of the Chimera engine and the Quarter-Horse tests will be an important prerequisite for the dream of flying from New York to London in just 90 minutes to become a reality. Developing supersonic aircraft is a huge step forward in the history of aviation. But the journey is not easy. One of the biggest challenges is thermal management. When flying at extremely high speeds, the friction between the air and the aircraft surface will generate enormous heat, which can damage the engine and important components. To solve this problem, engineers need to develop advanced heat-resistant materials and efficient cooling systems. In addition, fuel consumption is a major issue. Supersonic flight requires a large amount of energy to maintain high speeds for long periods. This makes improving engine efficiency and optimizing fuel consumption a top priority. Engine systems such as Hermit's Chimera, a combination of a turbojet and a ramjet, have been studied to ensure operational efficiency at both low and high speeds. In addition, noise and flight regulations are also significant barriers. When a hypersonic aircraft exceeds the speed of sound, it creates shock waves that cause a loud explosion, sonic boom. This has led to many countries, especially the US, restricting hypersonic flights over land. Developers must find ways to minimize noise or request permission to test flights over sparsely populated areas. Finally, ensuring safety and meeting international aviation standards is a big challenge in the process of commercializing this technology. Hermit's success comes not only from its technological capabilities but also from strategic investment capital from large organizations. Notably, the U.S. Air Force and Sam Altman, co-founder of OpenAI, have poured hundreds of millions of dollars into this project. This is not just a simple financial investment, but also demonstrates strong belief in Hermit's potential in the field of aviation and hypersonic technology. The support from defense organizations such as the U.S. Air Force also shows the potential military applications of hypersonic aircraft. Hypersonic aircraft could become a strategic weapon in the future, with the ability to rapidly deploy globally, attack targets or perform surveillance and reconnaissance missions in a short time. This is an important advantage in the context of increasingly fierce competition in defense technology between major powers. In addition, this potential also extends to the field of space exploration, when hypersonic technology can play a supporting role in short-term space flights. The combination of technical talent and strategic investment capital has created conditions for Hermet to develop rapidly. This is a clear demonstration that large organizations value hypersonic technology not only in terms of commerce but also in terms of defense and global security. Hermet is setting an ambitious goal: to break the speed record of the state Route 71 Blackbird by 2025. The state Route 71, nicknamed the legendary Blackbird, is the fastest spy-plane ever built, reaching a top speed of 2,193 miles per hour, Mach 2.85. Breaking this record is not only a technical achievement, but also a symbolic one, marking a new era in supersonic aviation technology. If successful, Hermet will demonstrate that its Chimera technology and Quarter-Horse system can reach speeds of Mach 4, about 3.069 miles per hour. This would be an unprecedented leap in aviation history, paving the way for the development of commercial supersonic aircraft, where transatlantic flights could take just 90 minutes instead of the current 7 to 8 hours. However, to realize this goal, Hermet still has to overcome many challenges. In addition to technical hurdles such as thermal management, fuel efficiency and aerodynamic design, they also need to address regulatory and environmental concerns. The noise and emissions of supersonic aircraft could face backlash from regulators and the public. Despite the challenges, Hermet's rapid progress is a testament to a promising future. If their plans succeed, the world could witness a revolution in air travel, shortening the distances between continents, bringing huge benefits in terms of time and global connectivity. Despite the challenges ahead, with the strong investment and rapid progress that Hermet has made, the future of supersonic travel is becoming clear and promising. If this ambitious plan is successful, we will witness a revolution in the long-haul aviation industry, where distance is no longer an obstacle and time is shortened incredibly. Thank you for accompanying and watching today's video. If you find it interesting and useful, don't forget to like, share and subscribe to the channel to update the next interesting content. See you in the upcoming videos. Wish you a great day.